Hi everyone, it's me, Bon, and welcome to my third daily edition. This daily edition will mainly focus on the concepts that I learned from the daily edition, the solutions from my daily edition 3, and my conclusions. So, for this daily edition, there wasn't anything new except for negative or negated exponents, which I found really difficult. For example, in question 2, there's a negated exponent that requires me to switch up the reciprocals of a fraction in order to find the solution. So, next, here are my solutions for DE3 and the explanations on how I did them. For the first question, which is 2/5 squared, talks about the solution for this. So, how I did this was that I took 2 squared over 5th squared, which is it was actually 3, which equals to 9 over 25, which is the solution for question 1. For question 2, 4 nines upper the negated exponents by 2, which I switched it up to 9/4 squared, which equals to 9 squared and 4 squared, equaling to 81 over 16. For my third 2b, which is a minus n over b minus n, is solved by taking 1 over a to the power of n plus divided by 1 over b to the power of n, which equals to 1 divided by a over the power of n multiplied by b, 1 divided by b in the power of n, which equals to b to the power of n divided by a to the power of n, which eventually becomes b divided by a equals b divided by a to the power of n, and equaling to a divided by b. Because of the negated exponents, which switches them up, it becomes a divided by b on negated exponents by n. C. Prove that a negated exponent n divided by b minus n equals a divided by b to the negated exponent of n. I think that's how it's called. So firstly, I take 1 divided by a to the power of n and divide it by the result of b divided by 1, b to the power of n divided by 1, which should equal to 1 to the power of a to the power of n equals to n x and the y reciprocals, which according to the formula should be equal to b divided by a to the power of n. Now, to find the opposite, which is firstly I found the a to the power of n minus to b to the power of n minus. So now I need to do it in reverse, how I divide 2 by 1, which equals 1, and then I have to multiply by 1 to 2 to equal the correct answer. So, since taking back the original complications, the formula, it equals to b divided by a, the result of b divided by a to the power of minus n. So, that's all for questions 1 and 2. Next, question 3, which focuses on 1 minus plus 1 over 2 plus 1/2 to the power of 2. So, in order to solve this, I first solve the ideas and problems in the brackets, which is 1 plus 1 over 2 plus 1/2. So, 1 over 2 plus 1/2 equals 5 twos, because 2 plus 1/2, 2 is 2 because the denominator is 2, which equals 5/2. Next, I'm going to take 1 plus 1 and 5/2 because that's what I got for the answer, and I'm going to add it back to the bracket, which also, because of the reciprocals, I have to reverse them and hence the correct one is 1 plus 2 over 5. So after I add those back into the bracket, the amount of numbers I get is 1 plus 2.5, 2 over 5 plus 2 over 5, which equals to 7 over 5. And square that up, which means 7 multiplied by itself over 5 multiplied by itself, which equals to 49 over 25. Now, 4. So, the question is, if A is more than B, and B is more than C, and C is more than D, what is A plus C compared to B plus D? Is it more, is it less, or is it equal? So, since A is bigger than B, and B is bigger than C, and C is bigger than D, for example, assume that A is 4, B is 3, and etc. A plus C, which is 4 plus 2 equals 6, and B plus D, which is 3 equals 1, is only 4, which means that A plus C is more than B plus D. Next, since A plus C is equal to A plus C, there's no need to explain that. However, B plus D is less than A plus C because that's just in reverse. So, in conclusion, the main concept, I think, the idea of the DE3 was to teach us about the ideas of negative or negated exponents, which I find difficult. Well, I learned something, and these are my solutions to the DE3. Have a nice day. Goodbye.